Lesson 4.1, Graphing Equations in Slope-Intercept Form. Our essential question is, how do you graph an equation that is written in slope-intercept form? Well, slope-intercept form is y equals mx plus b. We've already worked with this form. The only difference is it was written in function notation before, so it used to say f of x equals, but remember that's the exact same thing as y equals. F of x just means a function in terms of x as your independent variable. So the m in our formula, you should recall, stands for the slope, and then the b stands for the y-intercept, where the graph crosses the y-intercept. The first few problems are a review. It says graph the equation y equals 1/2 x minus 4. What we've done in the last chapter was we looked at the graph and we wrote the equation. So now we're just reversing that process. And instead we're giving you the equation and asking you to draw the graph. So the 1/2 represents our slope for our line, and the -4 represents the y-intercept. So I am going to start my graph at the y-intercept. -4, which is right here, down 4 from the origin on the y-axis. Then I can use my slope. My slope represents the rise over the run. The rise is up or down, and I always run over to the right. So I'm going to rise 1, and then I'm going to run 2. So that's going to give me a point right here. Then I'm going to repeat that process, rise 1, run 2, and now I've got 3 points on my line. So I can draw my line. Remember that a line goes on forever in both directions. So you should have arrows on both ends of your line. It's not a segment and it's not a ray. So put arrows on both ends. So again, graph the intercept first, the y-intercept first, then use your slope to get 2 more points on your line. Next one. My slope is -2, and +5 is my y-intercept. So I start out at +5, right here. My slope, rise over run. My slope is -2, so I'm going to put a 1 under it. So my rise is -2, I'm going to go down 2, and my run is 1 over 1 to the right. Down 2 for my -2, over 1 to the right. And then draw my line, put both arrows on. Okay, the next one says write the equation in slope-intercept form and then graph it. So now they're telling us the slope and they're telling us the intercept. So we just need to plug them in and then graph this. So if I plug in my slope 3/4, that is going to go in front of x, and then I plug in my intercept, -2, that goes after the x. To graph it, just like the last two, my intercept is where I start, so start out at -2, and my slope, rise over run, so I'm going to rise 3, run 4. So I go up 3, and then I'm going to go over 4 to the right. Up 3, over 4, and then draw my line. Another one like that. So write your equation in slope-intercept form. Slope, -2/5. So put that where the m is in front of the x. Intercept, +3, so +3. Start your line at the intercept, and then use the slope, -2/5. So rise over run, -2, so down 2/5. Now, if you wanted to, instead of continuing your graph to the right, going down 2/5 again, you could reverse that process, and you could instead go up 2 and then back 5, and you should see that this point still lies on the same line, because that line continues in both directions. So you can choose if you want to continue going to the right or if you want to balance it to the left. Okay, now the tougher ones. What this problem is asking is, it's asking us to rewrite the equation into slope-intercept form first, then graph it. Slope-intercept form is y equals mx plus b. So you may notice that that means that the y is all by itself on the left-hand side of the equal sign. So you need to treat this as a literal equation and solve the equation to get the y all by itself on the left-hand side. So I'm going to treat this 2y as my married couple. I'm going to subtract the 3x on both sides. And when I bring this down, I'm going to make sure that I write the -3x because it's got a minus in front of it. So remember that's the same as adding the opposite. So a -3x, then plus the 6. The 6 is a positive. The 6 has its own sign. So the 3x had the minus in front of it, not the 6. So, and I'm writing them side by side in that order so that it matches the order of our slope-intercept form. After the equal sign, we have our x term, then we have our intercept. Now, the second step you should remember from literal equations in chapter 2, divide everything by 2. Now, when you divide both sides by 2, you should write the slope fraction separate from the intercept like this. So it's -3/2 x, and then plus, so I'm kind of going like this, like a butterfly. I'm dividing each term by 2. 6 divided by 2 is 3. So my equation in slope-intercept form has a slope of -3/2 and an intercept of 3. So slope, rise over run. Intercept is where I'm going to start my graph at +3 on the y-axis. So from that intercept, I'm going to rise -3, so down 3/2 to the right. Down 3/2 to the right. And then draw my line. So the new step is the trickiest one here in this section. It's remembering how to solve a literal equation for a given variable. And in slope-intercept form, that given variable is always the letter y, because the y has to be by itself on the left-hand side. Okay, another one like that. Solve for y. So, this is my married couple. I'm going to have to subtract the 6x because it's a positive 6x. The signs on this problem are a little bit tricky, so be careful. So my 6x is gone. I bring down my -4y because the minus that was in front of it means it's a negative. Then side by side, I'm going to write -6x and then +12. -6x plus 12. Okay, now when I divide, to get the y by itself, I have to divide by -4 to cancel out the -4's. I am going to divide individually because this is the option instead of just dividing the whole right-hand side by -4. Because I butterfly split it on the last one anyway, I'm just going to divide them each by -4. Negative 6 over negative 4, that fraction reduces to a positive 3/2. The two negatives cancel out. Positive 12 divided by negative 4 is negative 3. So now my slope is positive 3/2, because a negative divided by a negative is a positive. And of course, remember it's rise over run. And then remember that my intercept is where I'm starting my graph, negative 3 on the y-axis. From that point, rise 3, run 2. Rise 3, run 2, draw your line. And we're done. Okay, this next one, y equals negative 3. Well, this is already written in slope-intercept form. Now, what you need to remember, we talked about in chapter 3, but this is tricky. This is really tricky. When you look at your slope-intercept form, the question is, what does this negative 3 represent? Does it represent a slope or an intercept? Well, it does not have an x attached to it. So that means that it is not a slope. It has to be an intercept. So I want you to remember that if you have only an intercept and the slope piece is missing, it means that that slope is 0. That slope is 0. Because 0 times x is 0, so you don't have to write it. So it's the exact same thing here and here. Those equations are the same, okay? So my intercept is negative 3 on the y-axis. My slope is 0. So hopefully you remember that represents a horizontal line right there. Every single point on this line, every point on this line has a y-coordinate of negative 3. So we've got the intercept, which is like 0, negative 3. We've got a point over here, like this point, for example, is 4, negative 3. This point over here is negative 4, negative 3. Every point on that line, y equals negative 3 for every point on that line. So that equation, y equals negative 3, is the horizontal line, including all of those points. So similar to that, when it's just x equals 2, on the x-axis, 2 is right here. So when you've got one variable in your equation and that variable is x, that is going to give you a vertical line. Vertical lines are x equals something. Horizontal lines are y equals something, a constant. And I could say x equals a number, or y equals a number, a constant number. So when there aren't two variables in your equation, it's going to be a more basic line that's horizontal or vertical. And you just have to remember which is which. So all of the points on this line have x coordinates of 2, 2, 0, 2, 2, 2, 5, and so on. So for every point on that vertical line, x is 2. Like on the last one, every point on the horizontal line, y was negative 3. Okay, it's time to write your summary. And your homework problems, page 217 to 219, 1 to 14, and 15.